In this problem, we will need to simplify the given expression. So let's begin by first stating the De Moivre's theorem, which states that whenever we have cosine of theta plus iota times sine theta whole raised to the power of n, so this is also equivalent to cosine of n theta plus iota times sine of n theta. If we want to write this in a compact form, so this will become cis of theta all raised to the power of n, and that's equivalent to cis of n theta. So here the cis, the c stands for cosine, I for iota, and s for the sine function. So let's use this theorem. Now we will begin with our first expression, which is cosine of 3 theta plus iota times sine 3 theta whole raised to the power of 4. Now if we apply De Moivre's theorem, cosine of 3 theta plus iota times sine 3 theta, so that's actually cis of 3 theta whole raised to the power of 4. Now cis of 3 theta, this can be also expressed as cis of theta whole raised to the power of 3 and whole raised to the power of 4. In other words, this will be equivalent to cis of theta raised to the power of 3 times 4, so that's 12. So let's keep it aside for the time being. Then we will begin with the other expression, which is cosine of 5 theta minus iota times sine 5 theta whole raised to the power of 4 over 5. So this will be equivalent to cis of, so here we have negative I times sine 5 theta, so this will become negative 5 theta whole raised to the power of 4 over 5, which will be equivalent to, so here we have cis of theta, this will be raised to negative 5 whole raised to the power of 4 over 5. Right. So when we multiply negative 5 with 4 over 5, so we'll get cis of theta whole raised to the power of negative 4. Then coming to this particular expression, so we have cosine of 9 theta over 2 plus iota times sine of 9 theta over 2 whole raised to the power of 2/3. So this will be equals to cis of 9 theta over 2 whole raised to the power of 2/3, which will be equals to cis of theta whole raised to the power of, so we'll have 9 over 2, and this is raised to the power of 2 over 3, so we'll simply multiply to 2 over 3. So 9 over 2 multiplied to 2 over 3, so that's simply cis theta whole raised to the power of 3. Fine. And coming to this final expression, we have cosine of 4 theta over 5 plus iota times sine 4 theta over 5 whole raised to the power of negative 10. So this will become cis of theta whole raised to the power of, so we'll have 4 over 5 multiplied to negative 10, so this is simply 8, negative 8. So now that I have all the expression written in this simplified form, so we have 4 of them. Now what we'll do, we'll write each of them in place of their original expression. So let's begin. This is going to now give us, the expression will now become cis for the first one, cis of theta whole raised to the power of 12. This will be multiplied to the second expression, which is cis of theta raised to the power of negative 4, divided by the third one in the denominator, which is cis of theta whole cubed, and the final one will be cis of theta whole raised to the power of negative 8. Now using the laws of indices, we can combine all of them. So we have cis of theta whole raised to the power of, we have 12 added to negative 4. Then we'll subtract each of the exponents from the denominator, because we are going to take them to the numerator and combine with the numerator. So we have negative 3 minus of negative 8. So this is going to give us, so we have 12 minus 4. So 12 minus 4, let's write it down. We'll do it in the next step. Cis of theta raised to the power of, so we have 12 minus 4, negative 3 plus 8. So we have negative 4 and negative 3, so that's negative 7. Negative 7 plus 8 is positive 1, so 12 plus 1 will be 13. So we have cis of theta raised to the power of 13. Now cis of theta raised to the power of 13. Let's simplify CIS of theta whole raised to the power of 13 using de Moivre's theorem. This is equivalent to CIS of 13 theta, or simply put, we have cosine of 13 theta plus iota times sine of 13 theta. So this is the simplified form of our original expression.